This is the T1 that I built. You may have seen it running around the layout. There we go. Anyway, that started out as two Rivarossi chassis that were basically no good. I used the worst parts I possibly had. The spares that were no good that I didn't want to use because this was an experiment. And the next one I build is going to run a hell of a lot better. And this one actually runs pretty good. So what I started out with was two Rivarossis like this. I'll start with the rear truck because it's easier. The one that I converted for the back. I lopped off the frame about right here. I took this off. I sectioned it, I made it shorter. You have to grind the insides so you get closer to the pistons to get to pull in. And then I have to change the height, so I had to grind the inside of that so it sits at the same height. And you look at this one here, and you notice that this is closer to the wheels than this one is. See? So you have to move it back a little bit. And that's basically it for the front. For the rear. The motor is slightly at an angle. It's mounted on rubber blocks that I sanded down so they would be shaped like a wedge. I used 1.5 millimeter inside diameter, 3.5 millimeter outside diameter food silicone hose. In short, the short length, it won't twist. As long as you don't have too much more than maybe 3/8 of a gap between shaft to shaft. If you have to go further and you're at a slight angle, you want to put something solid in the middle of it so it can't fold over on itself. So as far as gluing it to that, what I did was I used shrink wrap. I put shrink wrap on it, but I put super glue on it. I also sanded it down a little bit, scuffed it. Did the same thing with the motor shaft itself. Now, onto the front. The front one's a little bit more complicated. Well, not really. So, same deal. You have to take the pistons off. You got to move them forward, but you want to keep the same distance that they originally had. You want to lop this down in the middle and shave the insides and the bottom so it sits at the same height but closer. You're going to have to manipulate the rods a little bit so they don't interfere. All this stuff comes off. What I did with this piece here, this goes south. This piece here is not connected anymore. I cut it, I drilled this out, flip-flopped it, and glued it in here. Actually, I didn't glue it. I bent it so it would stay in. So I had to force it in. I had to shave the top of this piston down because it needs to articulate underneath the body. It needs to be able to, it can't be too much closer than that. And I bonded the trucks back to the frame by grinding the frame down a little bit and using super glue and baking soda. It's very strong if it's done right. There again, this has to be the right height. You can't have it too low or the wheels will hit the metal here and it'll short out. The transmission, I've removed the worm gear, flip-flopped it because I needed it pointing this way. You can't just pick this up and spin it because then it won't sit in the center. So you have to take the worm gear out, flip-flop it. Now, the motor went in the front. Same deal as the back, slightly at an angle. It's got to be a thin, small motor. I used a 3-pole crap. Got them from eBay motor because they were not so wide. Let me find a motor here. It'll look like this. And it basically sat like this, right above the trucks. There again, I used rubber blocks and mounted it at an angle. And this motor is narrow enough that it still would pivot in the shell just enough. Now, you don't. This thing will easily run. This one here, I modified it so it would run on an 18-inch radius because I'm going to have 18. Unfortunately, I don't have a lot of room to build a rail yard, and I'm forced to use 18 radius turns. So I belt sanded, wet sanded, so the plastic wouldn't get hot. I belt sanded the flange completely off the driver. But that's actually the last thing you want to do, because once you lop this frame and it has no front truck, no front wheels, it becomes, unstable. So you want it to sit flat. So basically, you have this transmission, and for argument's sake, we'll just flip this one around. Okay, and then you're going to have the motor here in the front. This would be gone, and the trucks would be basically, the pistons would be in the front, like they are right now. Now, to bridge them, this one here the rear one is stable. It's mounted to the train. I used the old Rivarossi frame that was no good because it fits right on here. It came straight off like this. I sanded this down. I glued it with baking soda and super glue. I also drilled a hole in the top of it so I could access the screw, so you could get at it. And then it has a bridge, and then on that, at the other end of the bridge, there's another piece of bracket that's mounted on the top of this that had, what I used was one of the brass studs that come off of this wheel. I soldered it to a piece of metal. I used little tiny washers to space it out just right, and it sat on here, and then it pivoted. If you can get that far, I'm sure you can figure out, maybe you have a better method. But basically, the pivot has got to be in the center of these two wheels, so it has even weight distribution, or the thing will tip up or down or whatever. So that's how I did it. And then, of course, I had to keep checking the height and tweaking the metal a little bit in the angle, so when I pushed on in the center of it where the weight was going to be, that all the wheels were touching at the same time. Once I got the height right and I knew it was going to work, I took the geared wheel, this one's geared, and I took the flange off of it. Now see this frame here? This was a frame, one of my first experiments. This frame was lopped off and then soldered back together. So the gearbox is here, unlike it being here. So if I had to do this all over again, because I want the gearbox in the front set of wheels, that way I have room for the motor, that way the motor is not in the cab, you might not care. You won't have to do all that extra work. I did it because I didn't want the motor in the cab. I actually wanted to put weight there, which I think is a better idea. What you can do is completely reverse everything. The pickup on the wheels, once you flip-flop this, if you had it this way, this being the rear of the train, then you have your rear truck mounted here and all this stuff mounted in the front, and the gearbox facing this way, you could have your motor. you could have your motor sitting right on top of this, but it's probably just easier to leave the frame alone, chop it here, move the pistons in, and you'll end up with your motor. Where is the motor? Sorry, I'm doing this at work when I'm supposed to be working. I skipped lunch, so... Alright, I don't know what I did with the motor. It was here. Anyway, you'd have your motor sitting right here, and it would sit inside this cab. Mine is sitting... The back of the motor is right here. If you do it with this intact, the back of the motor is going to be right here. I wanted the weight. You'd still be able to put weight in it. It would just be underneath the motor. A lot easier. You cut out a step. You don't have to. Probably talking in riddles because I'm exhausted, but you won't have to do what I did. I did this purposely because I had already lopped this frame for something else, and I was using pieces parts. So there you have it. So there's a motor there. You can actually see it mounted at an angle, just like the Bowser's. That's basically where I stole this idea from. And this, I had to cut the back of the frame. This whole thing was like homemade. So pieces parts again. The transmission, where it normally screws in right here, I needed that space to get these wheels closer. So where it was threaded, I lost that. I grinded it off. In order to hold the back of the transmission, you see a bracket right there. That bracket goes through the train and down underneath, and it bends like just a bracket. Now in this train here, you're going to see a piece of silver. That's a spacer. Because why did I use a spacer? Oh, because that transmission cover, or whatever you want to call it, right here, came out of another train, and it looked like somebody grinded it down to get the gear closer to the worm gear, closer to the gear. And at the time, I only wanted to use junk parts to build this. So I compromised and I used something that was basically no good. And I just spaced it back up to the height that it needed to be. And then I had a bracket going from here down, shaped like a big clamp, like this, and then tighten it down so the back of the gearbox would lift up. But that's basically how I did it. It took about 3 weeks to build this. As far as the shell goes, shell is made out of Lexan. I'm going to open up a program on a computer here. That was my Hiawatha. Let's see. Let's see if I can find this. Alright, so let's see if I can find this here. So I do graphic arts at work. Also tint cars and wrap cars. So it's easy for me to use a computer to draw something out and cut it. It's not the same as 3D printing, but 3D printing kind of takes the fun out of trains. The whole idea of building trains is to start with nothing and make something. Okay, this page here was the shape that I needed for this. And what I did was I created this file here, and I put thin Lexan through the plotter, turned up the blade so it would push down, and had it plotted, and then I snapped it free. Hold on, I'll find another file here. Bear with me. T1. Oh God, you're killing me. It's in my way. All right. Might be this one. Nope. Yeah. Okay, I know what happened. I accidentally erased it. But I could basically show you the same thing that I did with the Hiawatha. What I did was I took a picture, flat, straightforward picture that's flat, opened it up on the screen, figured out how many inches this train should be in actual scale, which is just over 7.5 inches. So if you have one and you measure it, it's going to be about 7 5/8 inch long. So what I did was I picked a size, something close. That's how I used this. And then I drew on the board, on the screen, this. I plotted this out of the Lexan, and that's what made the side of my trains. I also did the same thing with the footing of this, the side. What are they? The walkway. I did the same thing with the walkways. Yeah, unfortunately, I made a mistake, and when I resaved the Hiawatha file, I went over the T1, which is horrible because I was going to build another one. Now I got to start from scratch as far as using a computer. But yeah. So anyway, I used the computer basically. Put an image on the screen, brought it to scale, and that's how I figured out where certain things were supposed to be, how long it should be. This particular one, I didn't use Lexan, I only used it on part of it. But this shape here, this I plotted out of vinyl, slapped it on a piece of 1/8 inch, well actually, yeah, 2 pieces of 1/8 inch, basically Sintra, which is like PVC but softer, and hollowed out the center of it, left the majority of it on the sides, hollowed it out so it would be rounded underneath. And the shell itself here was 1 inch and a quarter drain pipe for a bathroom sink. And I cut it up in sections, heated it up a little bit, changed the diameter on it, bonded each piece at a time. These aren't actually where the real seams are. You can't see them, but I put those there. Manipulated the plastic, super glued it, used baking soda to solidify it, make it really hard, and then worked my way down. This here is thin, narrower, less diameter and flat, and then this one steps up a little bit, and then this one goes back in a little bit, and then it basically stays consistently all the way to the tip. The tip I used the same plastic. I seamed it together, I cut it in sections and molded it together, glued it, and then the tip of this here was made out of PVC. I just grinded it and belt sanded it into shape. This stuff here is made out of Sintra, soft PVC. I hollowed it out, put a light in there. All this detail here, that's Lexan plotted by the machine. These little ridges, That's all vinyl. I cut strips of it and glued them down, stuck them down, put them through a heat cycle so they would shrink. In some cases I used 2 layers. I epoxy painted over them, a primer, to hold them to the train, and then, you know, sprayed it. This whole section right here, the tread, that was from a broken shell. I cut it in sections and bonded it together. This stuff here was all pieces of train, cut off of River Rossi tenders that were garbage that I didn't need. All this plastic. Now, on that train, I used PVC. I used Lexan. And you can see the piece of this T1. See the shape of it? It plotted it out, and then I just snapped it out. And then I had the size. That's how I made this entire train here, but that's how I made some of it. By using a computer and just the Hiawatha. I was actually lucky enough. I got a blueprint from 1939 on a PDF file, so I was able to get the real measurements of the train, height, width, all that. For the most part, I stuck to the correct measurements. I had to cheat a little bit here and there, but this train here is probably, I don't know what the scale would be, but if you bought this from whomever, Broadway Limited, this train here would probably be maybe a half an inch longer than the Broadway Limited one. Maybe. I needed the room for the motor to move back and forth. So, see how close the motor is to the tip? There's lead in the nose of this. And look how close that is. It's really close. There's only about 1/8 of an inch, so I couldn't spare too much space. I could have moved everything backwards, but then the rear truck would have looked completely out of place, and it would have basically been underneath the ladders. So that's basically what I did. If you have any questions or anything, shoot a comment. I'll try to answer them. Thanks for watching.